Hello, I want to introduce another one of my blog posts in this continuing series about some of the background supplemental information about the key concepts in some of these blog posts. So this one is one about OM246, which you may have heard of. This hashtag OM246 stands for the total organic material at the 0 to 2, 2 to 4, and 2 to 4, and 4 to 6 centimeter depths right below the soil surface. And this is something that turns out to be incredibly useful. And I did a blog post that summarizes the bullet points of that. That's on my website, asianturfgrass.com. And I'll start sharing my screen here and show this to you. I'm going to put a link to this blog post, the soil organic matter bullet list, right down in the description of this video so you can find this. And this soil organic matter bullet list is something that summarizes the key points of this. And I think there's a few key points that I want to emphasize. I'll scroll down here to this image that shows the bullet list. I think the first thing that you should be aware of is standard soil tests for organic matter. They exclude thatch. By definition, soil organic matter is the organic material in the soil excluding undecayed, living, and dead plant and animal material. And thatch is an intermingled mix of living and dead undecomposed organic material, basically. So when you're testing organic matter, it takes away the thatch. And that can be problematic if you're designing your organic matter management program of verticutting and top dressing and core aerification to deal with and to manage that organic matter. So the organic matter measurement that is returned by an OM246 test is designed specifically to measure everything. It doesn't screen out, it doesn't remove any of the undecomposed material. And it's also done at very defined depths, whereas a typical soil test, a standard soil test, will be at 3, 4, 6 inches, something like that. I like the 4-inch depth, 10 centimeters. Some people like to go shorter, 7.5 centimeters or 3 inches. Regardless, if you're going that far below the surface, you are not really measuring exactly what's happening at the surface. You're measuring through the entire root zone. Now that's a useful measurement, but I think it's useful to make a supplemental measurement, the OM246, and measure exactly what's happening right at the surface. And another thing, another key thing with this that I would like to point out is that when you do this, you'll find that the organic matter over time tends to change quite a bit in the top 2 centimeters. Now that's 0.8 inches. It's a little bit less than an inch. So by testing in increments of centimeters, one can be a little bit more precise about what's going on rather than testing in inch increments. But when you look at the 2 to 4 centimeter depth, just getting, this is about 2 centimeters. So this is what's happening right at the surface. You go down to here, just another 2 centimeters down, and there's not very much change compared to what's happening at the surface. And if you look at the 4 to 6 centimeter depth, we're dealing now with a depth of less than 3 inches below the surface. So it's really close to the surface. The organic matter doesn't change very much. So the question becomes, if we are measuring the organic matter and it's not changing very much, do we really need to be pulling core? Do we really need to be pulling cores from down below the surface? Do we really need to be putting sand down there? That's a question that one asks after looking at these results, and it's really useful, I think, to check this at properties that you might be managing. So I've got all kinds of information and links in that post. It's one of the top posts on the site, the soil organic matter bullet list. And if we look at the projects page here, I'll show you one more thing about OM246. We can look at the OM246 project page. If you go to that, you can find a couple of things that I think are potentially useful for you. One is to look at the sample report chart, so you could see the type of report that I provide for OM246. And also you can look at sampling instructions for OM246. So that's how that works. I'll stop sharing my screen. You may see when I do that transition, there's a golf course, a few golf courses in a valley. That's one of my favorite photos of some golf courses in a cool part of Japan in Hakone. Those courses are down inside a crater, and I was up on a hiking trail on the caldera at Hakone. And there's some beautiful golf courses down there. Right. So I will talk just a little bit more about why this is something that I started doing. This test is something that I just find really useful because I'd been doing organic matter testing in various ways and trying to look at some specific depths. And every time I was sending a sample to a lab, this is back in 2015, 2016, every time I was sending a sample to a lab, it would turn out that we weren't doing a test that was what I really wanted. The test that I really wanted was, I'm going to send you a sample of soil to the lab, and I would like you to measure exactly what I send you, all of it, and just find out how much organic matter is in the material that I sent you. That's very simple. It turns out that that's what OM246 is as we've developed the test, but the problems that I was having is the other tests for total organic matter in the soil, they always ended up passing the sample through a sieve, even if it wasn't actually like written in the detailed instructions of how the test was conducted. It turns out that in order to have a certain A2LA laboratory certification for the test or something, every soil sample had to pass through at least a certain size sieve. So there was always a chance that some of that thatch, some of the undecomposed material would be screened out. And secondly, there was always a required sample size. So let's say that the sample needed to be 20 cubic centimeters or something like that, 20 cubic centimeters. If you scoop it at 20 cubic centimeters, but I've sent 50 cubic centimeters, then how can I be sure what actually is being measured? What if the way that the sample separates turns out to be a lot of the sand and soil material is easier to scoop, and it's more difficult to scoop some of the plant material that's there? So it's something where I always wanted to have a test where we just measure everything, and there's no question then about what's being measured. We're measuring everything that's being submitted to the lab. That's what the OM246 test is, and I've written a lot about it at my website at asianturfgrass.com. You can always find more information about this and a lot of other turfgrass topics right there at asianturfgrass.com. Another place where you can get more information, if you like Twitter, I'm at Asian Turfgrass on Twitter, and I send out various links to things that I find interesting or things that I've written or some comments about things that other people have done. And I appreciate you watching this, and I hope you'll check out the post. And I'm going to continue this series of introducing some of the new blog posts and some of the classic blog posts just to give a bit more information about them. Thank you.